Let's do another example with these discrete random variables, and we're going to once again look at expected value. Suppose you own two cell phone stores, one's located in a mall and one is located in a downtown location. And the following are historical sales data for each store by month. Now you're going to notice that there's probability distributions are shown in two ways. One way is as graphs, and the other way is in tables. Honestly, it's easier usually to read them in a table format. But can this also be displayed graphically? Definitely. We see that 200 phones at the mall, and I would say mall sales per month, or give a little more detail, but this was just a quick and dirty way to show you that it can be displayed this way. 200, that the probability of that happening per month at the mall location is 0.1. P of M is the probability at the mall of 200 phone selling is 0.1. And you notice that matches the detail right here. Same thing for the downtown location. We're going to use this information, and once again, it's the same information, but I'm going to use the table because it's a little easier to look at. What's the probability that more than 300 phones are sold at the mall next month? So we want the probability of more than 300 at the mall, and I'm just going to keep it brief. Now, am I going to look at M equals number of phones sold per month at the mall, or D, the number of phones sold per month downtown? And hopefully you're like, well, obviously we're looking at the mall only. So we're going to look here and say, okay, well, what's more than 300? Well, they could 350, and also we have something for 400. I'm going to take those two probabilities, add them together, and I get 0.4. Why can't I just add them together? Think about it this way. Are selling 350 phones and 400 phones, are those mutually exclusive of each other? If you sell 350 phones, have you sold 400? The answer is no. What's the probability that at least 200 phones are sold downtown next month? You have to be really careful reading these. This said more than, so we didn't want to include the 300. Here, though, at least we want to have at least 200 phones. And this is the downtown location. So we're going to start here at 0.45 and add the 0.15 and the 0.05, coming to 0.65. I'm giving you this information. I suggest you work it yourself. Now, could you have used the complement rule and said, well, there's only 100 that aren't accounted for here. I could just do 1 minus the 0.35. Sure, you get the exact same answer. What's the expected number of phones sold monthly at the mall and downtown? Remember, we want that expected, that long run average of phones sold. So what we're going to have to do is take each amount per month multiplied by its probability, and we're going to then add all those together. Why don't you take a moment, pause, write out the rest of this, and do the expected value of downtown also, and then come back. Hopefully you paused for a moment and finished that calculation, and you end up with 302.5 phones. And you may be tempted right away, oh, I got to round it, I got to round it. Remember, we're looking at 1 month here, and we're going to be looking over many, many months. Let's say 10 months. As soon as you multiply that by 10, the decimal goes away. So we're just going to leave decimals, even if you're talking about half a phone, half a person. It feels weird, but it's fine to do. The expected value for the downtown location is 190. And I wanted you to do that one on your own, but there's your check figure. What's the expected total of both locations? Can we just add them together? And the answer is yes, because remember, if they bought a phone at a phone, so you have a phone in your hand and you bought it at the mall, you could not have bought that phone that you're holding in your hand also at the downtown location. So you literally can just add them together. If you wanted to be conservative in terms of looking at sales, you could round down. Ultimately, if you were presenting this just as averages, you wouldn't want to round up, even though it's 0.5, because remember in accounting when we think finance, we'd want to underestimate versus overestimate sales. And of course, as a sales team, you're going to want to overestimate. Now, what about the difference between the two? Same idea. They're mutually exclusive. We can just take the difference. And I'd like you to pause for a moment and show how you got that number, or how I got that number. Now, the leasing costs are higher in the mall location than in downtown. As a result, you make $25 profit on each phone sold at the mall versus $35 for each phone sold downtown. What's the expected profit for each location? Don't make this hard. We want to think about the mall. So we're going to look at the mall. I know what the expected value is for each phone at the mall. Hopefully we would all agree. The expected value is 302.5. If we know we're going to make $25 on each of those phones, we can literally just take $25 times the 302.5. And we're going to have $7,562.50. If you use the same rationale for the downtown location, you're going to end up with $6,650. Are those closer than you expected? Or, or are they farther, or are you probably not necessarily thinking about in terms of that? But if we look at the counts, it seems like mall is going to sell a lot more phones. But remember, the mall is also more expensive to maintain that store or to rent that space. So your profit ends up not being as high. To get the total expected profit, we would just add the two numbers together and we get 14,212.50. Now, the last question is, how many phones can we expect to sell over the next 2 months in downtown? Well, we know that from part C above that we expect to sell 190 a month. And if we do that for 2 months, we're going to have 380. Does that mean there's a guarantee that we will sell 380 phones? Absolutely not. This is over the long run, many 2 months of sales together. We would expect on average in the long run to sell 380 phones over 2 months, but that is not a guaranteed number. Now, this next example is talking about a roulette wheel, and I would like you to pause and write this out. I'm going to start just by saying, as we think about it, take a pause and read the question, please. For part A, it wants us to do the probability distribution. So the possible values. And on an exam, I would be very clear that I wanted the probability distribution. C is for the net profit from a $1 bet on a color. So you have two choices. You can either win a buck or you can lose that $1 that you have because you bet it and you didn't land on the right color. Now there are 38 total slots. 2 of them are green, and green does nothing for you. You can't win on green. Green doesn't help. But if you bet, let's say red, there are 18 red slots, and if the ball landed on red, you would win a buck. So you would have $2 total in your pocket instead of you took that $1 out, slid it across, and then you would win additional dollar and you get your buck back. Now, on the other hand, losing, there are 20 slots you can lose on, which makes sense. Hopefully you think about gambling. Ultimately, the house wins. Over the long run, the house needs to win or they wouldn't be in business. Is this a valid probability distribution? Yeah. Each of the outcomes has a probability associated with it, and the probability is total to 1. So keep working that, and you can check your solution, check your answer for this problem in Canvas.